Hello there, welcome to new video of Software Engineering Unit 5. In this video, we are going to see graph. We have already discussed software testing fundamentals, fundamental white box testings, basic part testing. Today we are going to see about graph matrix control structures or graph based testing control structure in that one, and then we are also seeing some part of block box texting. What is black box? And in that one we are going to see graph based methods, correct? Now let's move on to this one, graph matrix. What do you mean by graph matrix or graph based testing? Graph matrix is a square matrix whose size is the number of rows and columns is equal to the number of nodes. Do remember, rows and columns are equal to number of nodes. Each row and column corresponding to identified nodes and matrix entries corresponding to the connection. So that's with the help of an address. By adding a link or if you give the weightage, we can have a matrix entity. Now let's take example. I have 1, 2, 3, 4. So I have got 1 to connection, 2 to connection, 3 to connection, 4 to connection, 5 to connection. I have got 1, 2, 3, 4. Now if I go to that 1, 2, 3, 4, 1, 2, 3, 4. 1 to 1 is 0, 1 to 2 it's 1, and let's say if I give 3 weightage, then I'll put a 3 weightage here. 1 2 3 1 2 3, I'll give 2 weightage, I'll go to 1 to 4, I'll get 6, I'll get this is how it is represented. Nodes are nothing but this one matrix, correct? And the weightage is given by the links, correct? And there is a column connection between them. The same way, example which I have solved there, and here also an example. We have got a flow graph. And which is shown in the help of a matrix. I have got 1, 3, or 2, 4, 5. So 1, 2, 3, 4, 5, 1, 2, 3, 4. 1 to 3 is A connection. 1 to 3 it's A. Weightage is A. 3 to 4. 3 to 4 it's B. Yes, it's B. And 3 to 2 it's C. 3 to C it's D. It's D. This is how graph matrix testing goes up, how it is represented. And control structures are nothing but we have got a conditional structures, conditional testing, a test case design method to exercise logical condition. This is used for logical condition, that is 0 or 1. Data flow, select a test path program according to the location defined by variables which are based on the logical condition. What are the variables we are using it? And we have got a testing methodologies, loop testing, white box testing technique focus on exclusive validation of the loop. So in the internal part we are going to see based on that one how the loop is identified or not. The loop testings are divided. It's a white box testing. Yes, it is a white box testing. Focus exclusive validation of the loop. Different types of loop are simple loop, nested loop, concentrated loop, constant loop, unstructured loop. So now let's take example. 5 is equal to 1, I less than my. If I go 5, I plus temp is 0, less than 5, while this statement are executed. So let's move on to this one. This is our simple loop and this is our nested loop, a loop in a loop. And consistent loop is something like that. A loop, first loop is executed followed by the next loop, and this is unstructured loop, correct? The diagram specifies this. We will see some theory part is in this one. The first one is simple testing. Skip the loop entirely, only one pass, two pass, m greater than n. So we'll go till n minus 1 or till n. So n maximum number of allowed passes. So I start with 0 or empty, not till I go 5. Now if I have 15, I'll start with 0, I'll go to 14. If I have 16, I'll go so on so. So this is simple part testing, one after the other. If you see here, the same example goes up, simple testing. simple testing will go up. This is the same path of it. Then we come up testing in nested loop. It start with innermost loop. Start with innermost loop. First one start with innermost loop. Then set all the loop to minimum values. Conduct a simple test for innermost while holding the outer word minimum values. So first execute the inner loop, minimum value for outer loop. So first we have to execute the workload, conduct test for the next loop, but keeping all outer loop to minimum and nested loop to typical values. So first we have to, if I have got 1, 2, 3, 4, this is nested loop, I have to condition all satisfied, then I'll go for this one, keeping the minimum value for outside. Okay, keeping the minimum value for outside. Next, testing in concatenated loop. Concatenated loop. Sorry, that's a spell. I cannot able to do it. For independent loop, same approach is loop. Otherwise, we otherwise use approach for nested loop. Independent loop, same approach, simple loop. If it is an independent loop, this is independent, this is independent, we follow same loop. If otherwise approach applied to the nested loop, otherwise approach applied as nested loop, this is applied as nested loop. Then we have got unstructured loop, redesign the code reflect the structural programming. Practice, then depending on the result reapplied it for nested, simple or concatenated loop, correct. Now this is the part of, I just told you up, we are part of this one, white box testing and soft black box testing. We wind up with white box testing. Now we are going to black box testing. What is the black box testing? The diagram shows up, it is for outside. Whereas, and it is called behavior testing. Whereas white box testing goes for inside. This is for outside. Means it looks for input, output, event and behavior. So internal, white box goes for internal testing by conventional different classes error, focus on functional requirements. The tester identifies set of input that will fully exercise on functional requirement of the program. Reduce that the number of additional tests based on your input and output. Black box testing, why you want to do it? Following things: incorrect or missing function, incorrect interface, error in data structures, behavior or performance error, initializing and terminating error. These are the things we are looking for it. Question answer, is the function what you tested is valid, is the behavior, system behavior and performance is good, the class input is good, particular sensitive, case sensitive, boundary values, volumes are being checked here. We are going to see all those in black box testings. Black box testing is divided into graph-based, equivalence, boundary values, comprehensive testing and orthogonal. So we are going to see only graph-based testing. What do you mean by graph-based testing? Here we have got object 1, object 2, object 3 and these are direct links. What do you mean by that one? An example which is given, and if you have a word file, word file, when you open the word file, then you open a documentation with this have a direct links and how much time it will take to open that links, and then in that word file you open it, you write something, it has a direct link, so you are writing, then your document test, that is the same part, then you will save it. Now let's take an example, you have open a documentation from the menu, go to the word, then you open this one, then you start writing, you open this one, it's opening, but you are opening this one, it is not opening, means you have here we cannot able to do this part, there is a problem. Direct links available here. Visualization software component with interaction of the graph and testing purpose to ensure all interactions are done correctly. Example, that's what I told you up. You have a menu we call it as to generate. You select a word, then you'll open a blank document, you select a blank document, that blank document is open, then you start editing it, or writing something, then what you will do, you go there and the top you save something, then come out. Let's take example, new file, select new file, then document has opened. That is a direct link, and the time taken for it 1 second. The time taken is 1 second, less than 1 second. Yes, it is you want to type it yet, then you are closing it. So these are all operation in that one are represent in this format, correct? Testing scenario, verify the selecting new file. Documentation windows, want verify the attributes of the windows, verify semantic relationship, verify relationship. If you see, all these relationships are available here. Types of graph method, transaction flow modeling, nodes represent step of transaction, nodes represent what it represent, transaction. Finite state modeling, node represent user observation, what is they observe and how much time they will take. Transformation, timing is representation. Here node represent direct link, what is that? Menu selected from that, how much time has 0.0, window open, attribute start, dimension, default, static, profit, contain. These are all represented here, correct? Timing and everything. I hope you got it. Thank you very much.